Hey everyone, my name is R Cubed. Welcome to a brand new science episode tailored towards science bull and general science learning. Today, we'll be discussing Isaac Newton's 3 laws of motion and Johannes Kepler's 3 laws of planetary motion. Who exactly was Newton? Why is he given the title of the most influential scientist ever? Kepler, Copernicus, what's the difference? What does F equals ma stand for again? Hey, those are all valid questions that we'll be answering in this video. Stay tuned. Born in 1643 in Woolsthorpe, England, Sir Isaac Newton began developing his influential theories on light, calculus, and celestial mechanics while on break from Cambridge University. Years of research culminated with the 1687 publication of Principia, a landmark work that established the universal laws of motion and gravity. Newton's second major book, Optics, detailed his experiments to determine the properties of light. Newton's first law states that every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of an external force. This is sometimes known as the law of inertia. Every object persists in a state of rest or uniform motion in a straight line, unless it is compelled to change that state by forces impressed on it. The second law explains how the velocity of an object changes when it is subjected to an external force. This law defines a force to be equal to the change in momentum, which is mass times velocity, per change in time. The formula for this is F equals ma, or F, the product of an object's mass, which is m, and its acceleration, a. The third law states that for every action in nature, there is an equal and opposite reaction. In other words, if object A exerts a force on object B, then object B will also exert an equal force on object A. Johannes Kepler was a German astronomer, mathematician, and astrologer. He is a key figure in the 17th century scientific revolution, best known for his laws of planetary motion. Johannes Kepler occurred around 1 century before Isaac Newton, or around 100 years before. According to Kepler's first law of planetary motion, planetary orbits are ellipses with the Sun at one focus of the ellipse. This means that even if they have the same size, ellipses with different shapes do not have the same center. In the diagram below, the focus of each ellipse is the same, for planetary orbits, the location of the Sun. As the ellipse becomes more stretched out, it also becomes more eccentric, meaning that the focus is further and further from the center of the ellipse. Close to the Sun, a given arc sweeps out a small area. Further away, it sweeps out a larger area. This means that it takes less time to cover an arc close to the Sun, so the planet must be moving faster, and more time to cover an arc further from the Sun, so therefore the planet must be moving slower in the other case. In other words, the law of areas implies that as planets move away from the Sun, they slow down, and as they move toward it, they speed up. The third law of Kepler states that the square of the orbital period of a planet is directly proportional to the cube of a semi-major axis of its orbit. This captures the relationship between the distance of planets from the Sun and their orbital periods. The third law can be understood more by looking at the mathematics of it all, but for this video, the purpose is mainly to distinguish the difference between the different laws for science bull and general learning purposes. So as a quick recap, today in our Cube series, Everything Science, today we learned about the 3 laws of planetary motion by Johannes Kepler and the 3 laws of motion by Isaac Newton. Through the diagrams on the slides, we were able to visualize these topics successfully. In Science Bowl toss-ups, you will be able to use this video successfully to quickly get the right answer of these 6 different laws. Make sure to subscribe so you can support our channel, and also so you can get notified whenever we post a great science episode like this one. Next time, we're going to be talking about the laws of thermodynamics. See you then!